Hi friends, like I promised, this is part 2 of Nature of Fruits. We are now doing examples. Let's take example 1. Given this minus 5 plus or minus root of 3 minus 12 k squared over 4. Okay, so the question is, determine the values of k for which the roots are real and equal. Real and equal. Now, real and equal. This is a guiding star. Real and equal. You go back to lesson 1. You check what is the condition for real and equal. Real and equal is the second condition there. The delta must be equal to 0. So we will go and apply that. Let's go back to our problem. Delta must be equal to 0. What is delta? We said delta is the stuff under the square root. So let's go take the stuff under the square root. It's 3 minus 12 k squared. That must be equal to 0. Now, all we have to do is solve for k. I'll transpose the negative 12k squared. It is negative here. It's going to become positive here when it jumps the equal sign. I'm looking for k, so I'll get rid of all the stuff without k. That's the 12. I'll divide by 12. I'll divide by 12 here. 12 will cancel 12. 3 over 12 is 1 over 4 equals to k squared. Now we can just apply square roots both sides. We're going to have plus or minus square root of 1 over 4 equals to k squared under square root as well. Square root will cancel the square. And then what do we have? We have plus or minus square root of 1 over 4 is 1 over 2 equals to k. You can leave it like this, or you can say k is, the first one is positive 1 over 2, or k is minus 1 over 2. And you are done. Those are the values of k, for which the roots will be real and equal. Okay, now let's take a second example. Example 2. Given x squared minus 2x minus k equals to 0. This time, we want the values of k. Determine the values of k for which the roots are non-real. Let's say non-real. So there is the guiding star. Non-real. That will tell us how delta should be. Let's go back. Lesson 1. Scroll up. Non-real. That's the third condition. What's happening to delta there? Delta must be less than 0. So we will go and apply exactly that. Let's go back. Great. So delta must be less than 0. That will give us non-real roots. Where do we get delta? Remember, delta is the stuff under the square root, or delta is given by b squared minus 4ac, since this is the stuff under the square root, okay, from the quadratic formula. So we know that our delta must be less than 0. Delta, okay, let me just write that. We know that our delta must be less than 0. Great. From this, a is that's the coefficient of x squared. B is that minus 2, and c is that k, minus k. So let's substitute. b is minus 2 squared, minus 4a is 1, c is minus k, less than 0. And then now we just have to solve for k. Minus 2 squared is 4. Minus 4 multiplied by 1 is minus 4. Minus 4 multiplied by minus k is going to be plus 4k, less than 0. Let's transpose this 4 so we can be left with 4k here. When it gets to the other side of the sign, it's going to become minus 4. We divide both sides by the 4 so we can be left with k. Divide both sides by the 4. Look at me. Why did I write that? It's minus 4. I'm so sorry. It's minus 4 here. K less than minus 1. So all the values of k that are less than minus 1 are going to give us non-real roots. Okay, and this concludes the series, the two-part series of nature of roots. The first part, I was introducing and describing nature of roots, and then the part 2, we were taking examples. Please be sure to catch both for better understanding. Thank you very much, guys, for sticking with me. I shall see you in the next series. God bless you. I can sing. Bye.